So whenever a question is there related to a turning effect, first thing what we consider, we identify the pivot. Means we consider a point around which the object can rotate. In this case, you have two possible pivots. You can have pivot at this pillar 1, or you can have a pivot at pillar 2. Only one side you can take a pivot. You cannot take the pivot both sides. So example, I'm taking the first pillar as a pivot. So first we identify the pivot. We call this as a point of rotation or the pivot. Now, as first we identify the pivot, either you can consider the left-hand side pillar as a pivot, or you can consider the right-hand side pivot as the right-hand side pillar as a pivot. So both ways you can consider. So example, I'm considering, they mention what are the values for T1 and T2 when the van of weight 24 kilonewton is on the bridge 5 meters from the left pillar. So 5 meters from left pillar, because this distance is given. So I consider the left pillar as a point of rotation. First thing, we consider pivot. So we identify the pivot first. Now, what is the second point? The second point, we consider we will identify the direction of the moment and consider the object is in equilibrium. So we'll consider the object is balance or equilibrium, and we identify the direction of the moments. Like which direction the force is causing a moment. So this 24 kilonewton, which direction it will try to cause a moment according with reference to this pivot?
Clockwise.
Same thing, 100 kilonewton, which direction it will try to cause a moment?
It will be also clockwise.
Clockwise. T1 is acting on the pivot. So when force is acting on the pivot, it does not cause any rotation. Why? Because moment is force multiplied by distance. If a distance is 0, this T1 will not cause any turning effect. So we don't have to consider. This T2, it's acting upwards. So which direction it will try to cause a turning effect? Anti-clockwise. So this will be anti-clockwise. This will produce anti-clockwise moment. This will produce a clockwise moment. This will also produce clockwise moment. So whenever object is in equilibrium, the total anti-clockwise moment must balance with the total clockwise moment. So anti-clockwise moment is T2 multiplied by distance from the pivot. So what is the distance of T2 from the pivot? That's equal to 20. Equals the clockwise moment. So weight of the van and the weight of the bridge, both are causing a clockwise moment. So first weight of a van is 24 multiplied by distance. As I mentioned, the van is 5 meters from the left-hand side. So this distance equals to 5 meters. So 24 multiplied by 5 plus the weight of the bridge, the force of the bridge, that is 100 kilonewton. So 100 multiplied by distance from the pivot. Because they mention it's a uniform bridge, so whenever object is uniform, the weight will always act at 10. The center. So it will be 10. Good. So the total is 20 meters. So weight will act at a distance of 10 meters. So it will be 100 multiplied by 10. Now we simplify. This is 24 times 5 plus 100 times 10. That is 1000. And that total is divided by 20. What's the answer for T2? 24 times 5 plus 1000 divided by 20.
Equals 56.
So if T2 is equals to 56, so 56 Newton is T2. So which option we have T2 56? That's C. So that's why we don't, even I can solve for T1 as well. After getting T2, because we know T1 plus T2, which are acting upward. So after getting T2, T1 plus T2 should be equal to 124 because the total upward force and downward force must be equal. So T1 plus T2 is how much? 56. So that will go to other side. So 124 minus 56 will get 68. So C will be there. Why I ignore T1? Why I did not consider T1 in the calculation? Because the force is acting on the pivot. So when the force acts on the pivot, the moment is actually force multiplied by distance from the pivot. So T1 will have some force, but the distance from the pivot is 0. That's why the turning effect of the T1 is 0. So we don't have to consider whenever force acts on the pivot, the turning effect is always 0.